Hello, my dear students and the serious GATE and ESC 2026 aspirants. How is your preparation going on? I hope it's great, right? But don't give up. My sincere and my honest appeal to you is don't give up until the last day and until you come out of this exam hall. Continuous preparation is the best way, and being consistent, you will definitely grow and get better and better every day. So don't give up. Don't worry much about your preparation, time left, sir, last 40 days left, nothing to worry. Just go with free mind, continue to prepare until last day, and every bit of knowledge and every line of knowledge will help you to achieve something big and better. Okay? So all the best and keep studying. Now the intention of this booster course is to just give you some confidence. And especially I want to talk about the areas, okay, what can be expected. But I told, always I'm very practical teacher. I say that there is nothing like important or unimportant. So I told this question to my students, which is the most important subject? All. And which is the most important topic? All. But the intention of giving is just to interact with you, give you some confidence. So I have selected such problems which are typical, and in the process of doing, we do get, emphasized and cover all the basics again. Okay, myself, B.S. Krishnavarma, faculty in ACE Engineering Academy and ACE Online since 2009. Welcome to this booster revision course on GATE 2026, and I also believe ESC 2026. Okay, yes, ACE Engineering Academy and ACE Online has initiated this booster course to interact with you, okay, and raise your confidence. Now, yes, I am talking about my favorite subject and my subject, that is electrical circuits or networks. Okay. Yes, core booster series. Now, I am talking this first model. Yes, this model is, yes, you go through this. In the figure, 1 ohm resistance is connected across a source that has load line characteristics of V plus I is 100. So, he said that this load has a characteristics of VI line. Okay, it is a straight line. V plus I is 100. The current through resistor is dash. So, he mentioned that load line of this network is V, okay, plus I is 100, and is asking the current flowing at that instant. Now, there are two things to understand. The load line characteristics he gave, but operating point also he gave. Now, what is the operating point here? If you see, V equal to IR. So, there are two things to observe. The load line characteristics of the network, yes, V plus I is 100, and also the Ohm's law, which is satisfying at that steady state point, is V equal to IR. So, what is the other equation? This is the first equation. And the other equation is V equal to I into R. Of course, R is 1. That is second. Chalo, now solve 1 and 2. Okay. So, if you solve 1 and 2, and then is asking the current at that steady state operating point. So, if you solve 1 and 2, V equal to IR, that means V is I into 1. So, if you substitute there, I plus I is 100. So, 2I is 100. So, obviously, I is 50 amperes. I is how much? It is 50 amperes. Okay. So, option is B. Okay. So, yes, he gave the load line characteristics and also a steady state operating point for which the load is connected. So, both we are matching. Characteristics come when we test for different operating points. But it is also steady state operating point for this condition for which the network is driving 1 ohm was also given. So, we satisfied both. Yes, and answer is 50 amperes. Now look at this very interesting question. The intention of giving this is making it simplified. So I am starting from fundamentals here. Which one of the following equations is valid for the circuit shown below? He gave some circuit. He gave I1, I2, I5, I6, I3, I4 and I7. Okay, there are 7 branch currents, and is asking which one of the following is valid for the circuit shown. Now he gave sum of current 0. So obviously he is writing KCL. Sum of current 0 means obviously he is writing KCL, Kirchhoff current law. It is very true. Now, rather than writing at every point, you know, KCL is universal. KCL is valid in a mesh. It is valid in a node. Sorry, KCL is valid in a mesh or Gaussian surface. It is KCL node or Gaussian surface or any network, all incoming currents equal to. KVL is mesh or loop we talk. So, KCL is valid in a node, okay, or a device. Yes or no? Or a Gaussian surface or any grid, law of conservation of charge. Okay. Now, conventional way of doing is so many equations you may get. But observe, in the option there is something to observe. See, he is stressing on which current, which branch currents? 3, 5, 6, 7. Okay, stressing on these currents 3, 5, 6 and 7. So, this is 3, yes, this is 5, yes, and then is 6 and 7, 6 and 7. So is stressing on these branch currents. Now the normal way of writing, start some node, satisfy all these equations you have to solve. What is the reason? No need. But if you can cut the network into 2 parts involving these 4 branch currents, you can get a KCL. That is called what surface? Gaussian surface. That is what I was asking. I was pausing that to make you think. So KCL is valid in a node, in a Gaussian surface, in any element or network altogether. All incoming currents equal to outgoing. Because he is asking relation by writing KCL between these 4 branch currents, I will cut the network into 2 parts completely involving these 4 branch currents only. Chalo, see, I3, I6, I5, I7 na? So I will cut the network into 2 parts. This surface is called what surface? Gaussian surface. What is Gaussian surface? Gaussian surface can completely divide the network into 2 parts. Later we call them as cut sets. So Gaussian surface is a surface which can completely divide the network into 2 parts. So I am cutting this network completely into 2 parts. Now let us talk about this Gaussian. Now to this surface, all right going currents equal to left going currents. Chalo, to this surface, all right going currents equal to left going currents. That is the easier way to write. Otherwise, every node you start solving and substituting is hell of a time. Chalo, now all right going currents. Which are the right going currents? See, this I3 is right side. I3, I6 is right side. Okay. I5 is also right side. Is equal to left going current, equal to I7. So right going currents are I3, I6, I5, I7. I7 is ulta, minor. So now if I write in order, chalo, I3 plus I5 plus I6 minus I7 is 0. That is the meaning, sir. Okay, that is the meaning. So I3, I5, I6 are positive, I7 is negative. So option is D. Obviously, yes, option is D. Okay? Yes, you take option is D. Okay, D. Okay? Chalo. Now see a very interesting question. I want again everyone to look at this question, please. In the circuit shown in figure 1, okay, yes, I is replaced by the same figure 2. If the current I remains same, then what will be the value of R0? So the question is very simple, sir. He said that this circuit is replaced with this circuit, but for same current, okay, then what is the value of R0? See, for the same voltage, same current flowing means resistance has to be same. For the same current, same voltage it is going means resistance has to be same. But he changed the topology. He changed the values and he also gave extra. So what is the intention? If current remains same for same voltage, the effective resistance also should be same. So what I will do? I will equate this resistance should be equal to that resistance. In that process, I will find R0. So let us do. Now these are all parallel. Na? So let us say this is network 1. Okay. If I observe, because they are parallel and that 2 3 resistors parallel, don't use direct formula. If there are 2 resistors, R total is R1 R2 by R1 plus 2. More than 2 na. Chalo, first network 1. Let us say this is R total 1. But I will write 1 by R total 1. Why? Because they are all parallel. It is 1 by 8R. 1 by 8R. Okay? Yes, I will write neatly. 1 by 8R. Okay? Plus 1 by 16R. Plus 1 by 32R. Okay, now here if I take 1 by 8R common, it is 1 plus half plus 1 by 4. So if I take LCM 4, okay, let me do it. If I take LCM 4, 4, 5, 6, 7. So then from that R total 1 will be how much? R total 1 be 32R by 7. Okay, that is first case. Now in the second case, what happened, everyone see? Now first these 3 are parallel plus series should be the same. First let us take only this part. Let us say R total 2 dash something, because this is still not R total 2. R total 2 will be this plus this. So let us take this first. R total 2 dash. Again parallel na? So I will write like 1 by R total 2 dash is again 1 by R, 1 by 2R, 1 by 4R. 1 by R, 1 by 2R plus 1 by 4R. So in that regard, if I take 1 by R common, again 1, okay, plus half plus 1 by 4. So again, if you take LCM, this is again going to be, okay, 7. So here R total 2 dash is, yes, 4R by 7. Good. But what is still R total 2? R total 2 dash is only this part. But R total 2 is this R total dash plus R0. So finally this R total 2 is R0 plus R total 2 dash, which is R0 plus 4R by 7. Okay, now according to the question, if same current is flowing for the same voltage, the effective resistance should be same. So this resistance and that resistance should be same. So let us equate R total 1 and R total 2. R total 1 equal to R total 2. Chalo, if I do that, this R total 1, that is 32 R by 7. Okay, let me write 32 R by 7 should be, okay, yes, R0 plus 4R by 7. R0 plus 4R by 7. So R0 is 32R by 7 minus 4R by 7. So if you take R0 is, okay, this is clearly 28 by 7. It is 4R. It is 4R. So the question is simple that if I can replace this R0 with 4R, then in both cases current is same. So it is resistor reduction technique. Okay. So if same current is allowed for same voltage, but resistance has to be same. But in this case, only these three are parallel. In this case, apart from these three being parallel, there is another resistor. But the question is, if I can maintain this R0 value as 4R, then the effective resistance in the circuit of this and this remains same. So current also remains same for the same voltage. Okay, it is a resistor reduction technique. Okay, na? So this value we got here. Okay, and this total value including R0 we got here, and we equated, we got the value. Okay, so it is simple resistor, but be careful, sir. More than two resistors in parallel, don't do direct formula. Okay. Now this is a very interesting question here, everyone. A connected planar network has 4 nodes. Okay, a connected planar network has 4 nodes and 5 elements. Elements are branches. So a connected planar network has 4 nodes and 5 branches. Of course, the branch number he gave 1, 2, 3, 4. 4 nodes. You can also take this is node A, node B, node C, node D. Okay? Yes. Now this connected planar network has 4 nodes and 5 elements or branches. The number of meshes in its dual. See this question. The number of meshes in its dual. Right now, how many meshes are there? 2. But he is asking number of meshes in dual. Now let us write the dual. Now how to write dual, sir? I told you, sir, meshes become branches. Meshes become as. So mesh 1 is like branch 1. Meshes become nodes. Okay, I will take meshes as nodes, and there is also one reference. There is also one more reference. So the question is, for this given planar network, actually it is a graph. He is asking number of meshes in its dual. How to write dual, sir? In dual duality, meshes become nodes. 2 meshes, 2 nodes, but there is reference extra. Reference is mandatory. So I am writing this separately. So this is mesh 1 become node 1, mesh 2 become node 2, and of course this is reference, and this is reference. Now, what you do now? Yes, include the external branches of each mesh to external node, all the external branches. So include the external branches of each mesh to reference node and write it dual. Include the external branches of each mesh to reference node and write it dual. So if you observe, now 1 to 0 there is 1. Okay, 1 to 0 there is 1. 1 to 0 there is element 1, like that, 1. Okay, then again 1 to 0 there is 2. Series become parallel, dual, series become parallel. These two series become parallel. So again 1 to 0, 2, element 2 also. 1 to 0, element 2. Okay, then again, so external branches of mesh 1 are over. Now also write the external branches of mesh 2. Now 2 to 0, 4. Okay, chalo 2 to 0, 4. 2 to 0, 4. Similarly, 2 to 0, 5 also is there. 2 to 0, 5. So 2 to 0 also 5. 5. And finally, yes, common branch elements between meshes are referred as common branch elements between nodes as duals. Common branch elements between meshes are referred as common branch elements between nodes as duals. So now these two, 1 to 2 there is an element. So 1 to 2 there is an element which is 3. So this is the dual, sir. So first of all, in dual duality, meshes become nodes. Okay, meshes become nodes. Okay, this is node 1, node 2 and node 0. And then remaining all 5 branches. Now after writing duals, now clearly tell me how many meshes are visible. The number of meshes in its dual network are 3. Here see 1 mesh, 2 mesh, 3 meshes. So after writing the same network into dual, we get how many meshes? So answer is 3. Very good problem. Okay. So very good problem. I know this network is actually graph. Graph is a skeleton of a network represented by line segment. But that is the meaning. Chalo sir, very interesting calculation problem I am taking. Very interesting calculation. I want everyone to go through, read carefully and be ready. Okay, read carefully. He said that in the circuit shown below, the supply voltage is 100 sine. Okay, 100 sine 1000 T volts. Supply voltage is 100 sine 1000 T volts. The peak value of steady state current through 1 ohm resistor in ampere is dash. First of all, this is a sinusoidal circuit like Vm sin omega t. Vm value is peak. The peak value of steady state current through 1 ohm resistance. The peak value of steady state current. Okay, if you can find RMS peak is root 2, or if you directly find the function, because he gave voltage as Vm sin omega t, if you can also find current as Im sin omega t, the peak value is Im itself. But it is a reduction technique. But very interesting concepts are. See here. So he is asking the peak value of the current through 1 ohm with this voltage. Now let us reduce. But interestingly, a pure parallel LC are there. Can you remember what is this pure parallel LC combination which I told you? Can you remember? Pure parallel LC circuits are called ideal tanks, provided you operate them at its natural frequency. Provided you operate them at its natural frequency. Let us see, check that. So pure parallel LC circuits are called as ideal tank circuits. Ideal tank circuits. Chalo, first let us simplify by finding the impedance. Now if you observe carefully, everyone, see, if you observe carefully, let us calculate the impedance here. Now what is the impedance of this? Plus j omega L. Plus j omega is how much, sir? See, 1000 into L. So 1000 into 4 milli is 4 ohms. 4 ohms. And this is also minus j by omega c. So minus j by omega is 1000. C is how much? 250 microfarad. If you observe, micro 2 you take above. Okay, 250, let me know. Okay. Micro and milli kilo. Kilo by 250 also minus J4. See sir, interestingly, this is plus J4, this is minus J4. What is the net impedance? Z1, Z2 by Z1 plus Z2. So numerator Z1, Z2 is this into this, but denominator Z1 plus Z2 becomes 0. Denominator 0 means infinity, so it acts like open circuit. That means for this frequency, this is like an ideal tank. Ideal tank under resonance frequency is open circuit. For this, resonance frequency is this obviously. You can also check. You check omega naught of this 1 by root LC, this frequency is only coming here. You check omega naught is 1 by root LC. If you do that, this frequency is coming. That means indirectly here, this is plus J4, this is minus J4. See how good question in gate. Overall, Z1, Z2 by Z1 plus Z2. You see this into this, you will get how much? 16. By denominator, this plus this is 0. Something by 0 infinity. This acts like open circuit. Interestingly, open circuit. Okay? Then what about this, sir? What about this? Here also let us check. Again, this is plus j omega L. Plus j omega L. See, omega is how much? 1000. L is this. 1000 into milli 1. So plus j 500 ohms. Plus j 500 ohms. And what about this, sir? Minus j by omega c. Omega is how much? 1000 into micro. Milli 2. Okay. Milli. Milli you take kilo. Kilo by 2. This is also minus j 500. Interesting values, na, sir? Okay, interesting. That means for this also, though he gave different values of L and C, but if you check that omega naught as 1 by root LC, you will again get 1000. You will again get 1000. So here also if you do Z1, Z2 by Z1 plus Z2, Z1, Z2 is 500 square, but Z1 by Z1, denominator Z1 plus Z2 0. So something by 0 infinity. So this also amazingly acts like open circuit. So it is such a good problem in gate that if you don't identify this interesting behavior of ideal tank, and in both cases I am sure its resonance natural frequency is 1000. If you substitute that formula, omega naught is 1 by root LC. And you know ideal tank at its natural frequency acts as open circuit. Dynamic impedance I told in resonance, do you remember? So that is a concept involved. So ideal tank. And amazingly for that frequency both are open circuits because net impedance is infinity. So now I can write the equivalent circuit how, see now. Because open circuit, so finally this become 4 ohm, 1 ohm, 5 ohm, and this is open circuit, and this tank also is open circuit. Okay, this is 4, 1, 5, 4 ohm, 1 ohm, 5, and this is also open circuit ideal tank, that is also open circuit ideal tank, and there is supply which is 100 sine 1000 T. There is a supply, AC supply, which is of course 100 sine 1000 T. So now sir, now he is asking the peak value of current. Now as it is, if you calculate current, okay, for this positive cycle, what is the current? I is V by Z, but these two are open, so it is only 10. So overall current will be, yes, 100 sine 1000 T by total path impedance 4 plus 1 plus 5, 10. So I is 10 sin 1000 t. Now the peak value is how much? Peak value of the current is 10 amperes because he asked peak value, sir. Okay, the peak value of the current. If he is asking RMS, it is maximum by root 2, then 10 by root 2, 7.0. But peak value of the current is maximum by root 2 and it is 10 amperes. See how good, but interesting behavior of ideal tank elements, right? Very good problem. So in exam, don't panic, be careful with calculations and lot of patience and presence of mind. He will give such questions which are possible in 1 minute, sir. Not that he will give very tough. Okay. Now I am taking next question. This is one of the outstanding questions which I selected to explain to you. See this question, sir. If voltmeter V1 read 20 volts and voltmeter V2 read 9 volts, then voltage across capacitor alone. Okay, voltmeter V1 is reading 20 volts and voltmeter V2 is reading 9 volts, then voltage across capacitor alone is asking. Okay. Now, and he gave the supply voltage which is 15. No doubt, this is AC steady state. Yes or no? This problem is in AC steady state and these meters read what values? RMS values. But unfortunately, meters cannot read phasor. See, these voltmeters are moving iron instrument and they read the RMS values of the voltage. But unfortunately, they cannot read the phase angle. But you know, these voltages have both magnitude and phase because they are phasor sinusoids, of course. Now what I will do? Yes, he gave voltmeter reading is phasor sum of VR, VL and voltmeter V2 is phasor sum of VL and VC. Okay, and he's asking voltage across capacitor alone. So if you can do that phasor difference like subtraction, addition, you will get that answer. But the problem is, you know, any series RLC circuit can behave in 3 ways. 1, if XL is greater than XC, if XL is greater than XC, it is lagging power factor where VL magnitude will be greater than VC. Second, if XL is less than XC, it is leading power factor. And third, if XL equal to XC, unity power factor. So all these are possible. Obviously, sir, all these are possible here. XL greater than XC lagging power factor, XC greater than XL leading power factor, XL equal to XC unity power factor. All are possible here. But individual voltages he did not give. So that is the problem here. So in starting this problem, because he did not give individual voltages to directly declare whether it is lagging or leading or unity power factor, let us take carefully the techniques. One thing I will say, in this case, this is not possible. Why XL equal to XC case not possible? If really XL equal to XC, then the magnitude of VL equal to VC. But you know, in inductor, with respect to current, voltage lead by 90 and in capacitor, with respect to current, voltage lag by 90. But if VL equal to VC, then yes, because of XL equal to XC, the resultant voltage across this would be 0, na? Like 2 equal opposite forces. So yes, if 2 equal opposite forces come, the resultant would have been 0. And this voltmeter would read 0. So yes, if XL equal to XC, then VL equal to VC. But both are 2 equal voltages but opposite in phase and resultant would have been 0. Then voltmeter V2 should read 0. But voltmeter reading is given here, voltmeter. So this case is not possible. Understood everyone? Out of 3 cases, this case is not possible. Because if this case exists, voltmeter V2 should read 0. Why? Because VL and VC are 2 equal but opposite phases, resultant phase cancellation, answer would have been 0. But V2 reading there means this is not possible. So this case is not possible. But remaining cases are there. One is lagging power factor, one is, that is why it is a very critical MSQ question. But suppose first if I take lagging, so case A, if I take lagging power factor means clearly XL is greater than XC. For the same current in series, if XL is greater than XC, then obviously VL is greater than VC. VL is greater than VC. So if you observe, yes, I will take first current as reference. Series circuit na sir, current. With respect to current, which voltage is in phase? VR is in phase. What about the voltage in a pure inductor? In a pure inductor, with respect to current, voltage will lead by 90. And because it is XL greater than XC, VL should be greater than. So VL will lead by 90 and I will take more magnitude. This is VL. What about VC? In a capacitor, current will lead voltage by 90 or with respect to current, voltage will lag. And here XC is small, so this is small. XC is small, this is small. So this will be small. This is the phasor diagram for series RLC under the condition of XL greater than XC, okay, that is VL greater than VC. Now with this data, let us substitute what he gave. Chalo. Now first voltmeter V1 reading is 20, but V1 is the resultant of VR plus VL, VR plus VL. Chalo, if you observe, everybody, yes, if you observe, it is VR plus VL. VR plus VL, this resultant is voltmeter V1, which is how much he gave? 20 volt. 20 volt. Then similarly, voltmeter V2 is the phasor sum of VL VC. VL VC, how much he gave? 9 volts. Okay. VL VC. Adding to unequal opposite forces is subtracting only. This if you remove here. Okay. This much if you remove here. So this will be VL minus VC, which is 9 volts. And also according to the question, phasor sum of VR plus VL plus VC is total supply 15. VR plus VL plus VC is 15. Now see, VR plus VL, see VL plus VC we got plus VR. VL plus VC we got plus VR is total V, that is 15. So that is 15. Okay, we got everything now. Okay, voltmeter V1 reading, voltmeter V2 reading and total supply reading. Now from this, what is the final question? He is asking the voltage across capacitor alone. Chalo, let us calculate. Voltage across capacitor means this length, sir. This length means this length only. Chalo, all Pythagoras theorems, sir. Be careful. And calculators always using is not good. Now if this is 15, this is 9. What is this length? Root of 225 minus 81, root 144, 12 volt. Now if this is 20, this is 12. What is this length? Yes, if this is 20, this is 12. What is this length? Root 400 minus 144, root 256 means 16. Now common sense. This is 16, this is 9 means this has to be 7 volt. So obviously this also is 7 volt. So voltage across capacitor is, yes, 7 volt. Voltage across capacitor is 7 volts. Understood everyone? But this is which case? Lagging power factor load. Then comes the story, sir. What about leading power factor? That also you should check, na? Chalo. Now, if I also consider this as a leading power factor network, under leading power factor, we know XL is less than XC. Okay, XL is less than XC. So obviously, yes, for series circuit, current is same, but reactance less means VL will be less than VC. VL will be less than VC. Okay, VL will be less than VC. So in that regard, let me again do. Again, I will take current as reference because it is series. Where is VR? It is VR. Now VL will lead I, but it is smaller. VL will lead I, but it is smaller. Now VC will lag I, or I leads, but it is larger. But this is larger. Larger. Now if you add, yes, now if you add again, yes, from the data given, voltmeter V1 is reading phasor sum of VR and VL. Chalo, phasor sum of VR, VL. Yes, this is voltmeter V1. And how much he gave? 20. So this is voltmeter V1, this is 20. And voltmeter V2 is phasor sum of VLVC, how much he gave? VLVC, how much he gave? Yes, VLVC 9. Okay, VLVC 9. Okay, yes, VLVC. This you cut here. This much you cut here, and this length will be 9. At the same time, supply. Phasor sum of VR plus VL plus VC is how much supply? 15. So VLVC we got plus VR. So this has to be 15. This has to be 15. Chalo, from that I need voltage across capacitor. From that I want voltage across capacitor. Chalo. Now this is 15, this is 9. This has to be 12. This is 20, this is 12. This has to be 16. If this is 16, this is also 16. Then overall length is 25 volts. So VC is 25 volts. So this is an MSQ, multiple select question. Why it is multiple select question? Yes, there are two possible answers, sir. Obviously, there are two possible answers. Okay. See, it cannot be unity power factor. I told that if unity power factor XL has to be equal to XC, then voltmeter VT should read 0, which is not possible. But remaining both existed. So if you take XL greater than XC, lagging power factor, you will get 7 volts. But if you take XC greater than XL, VC greater than VC, you get 25 volts. So this is an MSQ. So in exam, both are valid. If you take lagging power factor, 7 volts is the voltage across capacitor. But if it is a leading power factor, it is also 25 volts. Very, very good questions are MSQ. So in gate, of course, MSQ he will mention, right? MSQ is highlighting and mentioning. So you have to be very careful to select, yes, MSQ. And there keep testing all options. And all the fundamentals you learn, all possible cases you have to check. And options are given as a test it. Okay, that is a better way. But he highlights MSQ by giving box near the question. Do you remember? So that is the way to check MSQ. Now another outstanding question here. Okay, I want everyone to listen here. Okay. Now this question is when the voltage V naught sine omega t is applied to a pure inductor, the ammeter shown in the figure reads I naught. Then if this combined voltage is given, how much? See, when this V naught sine omega t is given, then current is I naught. So let us first take that parameter. Now we know that I is V by Z. Okay. So according to him, this I is I naught. When what that voltage he gave? Yes, let us say that maximum value is V naught by pure Z na plus j omega L. Okay. Omega naught L is nothing but omega naught L. So let us take this as the reference for what is given. He said that in this circuit, if voltage V naught sine omega naught t is applied to a pure inductor, the ammeter is showing I naught. Of course, in AC circuit, ammeter reads what value? RMS value, root mean square. Okay. And that is, yes, I naught. So according to the data, this I naught is V by Z, but Z is pure inductor. Pure inductor is plus j omega L. J is operator, don't worry. Omega L is XL omega L. That means I naught is this. So now he is asking, but if the applied voltage is this, now see, applied voltage is V naught sine omega naught t, 2 V naught sine 2 omega naught t, 3 V naught sine 3 omega naught t, and 4 V naught sine 4 omega naught t, then the voltage would be dash. Now this is clearly Fourier series or not? See, fundamental, second harmonic, third harmonic, fourth harmonic means this is clearly what? Fourier series. Fourier series coming means original wave is sinusoidal or non-sinusoidal? Non-sinusoidal applied to linear load. So clearly, yes, clearly this is case 2. I told in power analysis and calculating currents, etc., there are 3 cases. Case 1, sinusoidals applied to linear load. Okay, that is circuit theory, network analysis, machines and power system. Case 2, non-sinusoidal applied to linear load. That is communication systems and signal system. Case 3, sinusoidals applied to non-linear load. That is power electronics and analog electronics. So all subjects come into these categories. But here you see, this is Fourier series. Why? Fundamental, second harmonic, third harmonic. So different frequencies means Fourier series. Fourier series coming means original wave is non-sinusoidal. Non-sinusoidals apply to linear load. So this is case 2. Then what you have to do? To get the overall current, let us apply superposition theorem. So let us take each component separately and do. First, fundamental component. So if I take fundamental component, that is V naught sine omega naught t. So from fundamental component, yes, this I1 will be, this again how much, sir? This is V naught by plus j omega naught, because this is also omega naught L. But according to the given data, already I naught is V naught by omega naught L. So here also this is I1 only. So this is finally I naught. So I1 is I naught. Then what about second harmonic? Second harmonic I2 will be, now what is the magnitude of voltage? 2 V naught. Magnitude of voltage is 2 V naught, but this is plus j omega L. Omega is how much now? In inductor reactance is plus j omega L na? 2 omega naught L. This is 2 omega naught L. Again you remove 2. This is again V naught by omega naught L. So this is also I naught now. So I2 is also I naught. Because magnitude has increased 2 times, but frequency also increased 3 times. Reactance increased 2 times. So voltage magnitude increased 3 times, but reactance increased 2 times. Magnitude of current same. Then third harmonic. Now third harmonic, let us say I3. Magnitude of voltage is how much? 3 V naught by plus j omega L. But omega is how much now? 3 omega naught. 3 omega naught into L. Again, yes, remove 3. We again get V naught by omega naught L, which is again I naught only. Because according to the question that is given as I naught na. And finally, if I go with I4, okay, magnitude is 4 V naught. Yes or no? Yes, magnitude is 4 V naught. And this is again plus j omega naught L, that is 4 omega naught L. Okay, that is coming again as V naught by, yes, omega naught L, which is again I naught. This is also I naught. So finally, all these fundamental components, second harmonic, third harmonic and fourth harmonic are same. Now what is RMS of everything? Root mean square of all the root means. Now IRMS is root mean square of all the root means. That is I naught square. This also is I naught square. this also I naught square and I naught square. So this is root of 4 I naught square. So this I RMS is 2 I naught. I RMS is 2 I naught. Okay, very interesting bit, But yeah, this is option D. So that is why, sir, understand what he gave, which case it is coming. Voltage multiple frequency means Fourier series. Fourier series coming means Fourier non-sinusoidal supply to linear load. Why it is linear load? Pure inductor. RLC loads are linear, na? Okay. But he gave the data that for this voltage current is I naught, then for this voltage how much? So Fourier series, and of course we applied superposition theorem by taking each component separately. You cannot calculate directly, sir, because this inductor is a frequency dependent component. And all frequencies together, how can you do? No, you have to apply superposition by taking different frequencies at different points and do. Okay, that is a very interesting concept. Now, very interesting question. I want everyone to read. Just read for a minute. If the resonance frequency of the circuit shown is 1 kilohertz, if the resonance frequency of the circuit shown is 1 kilohertz, then the resonance frequency of circuit shown in figure 2. Now, this is a series RLC circuit, sir. For a series RLC circuit, what is the resonance frequency? For series RLC circuit, F0 is equal to 1 by 2 pi root LC. And that how much he gave? Yes, it is 1 kilohertz. 1 kilohertz. Now, he modified the circuit by adding more inductors capacitor and is asking the resonance frequency. Now, let us also calculate. But here, 2 inductors are in series. What is the total inductance? 2L. 2L. And these 2 capacitors are parallel. What is the total capacitance? Capacitance is parallel. This is also 2C. So now the resonance frequency F0 is 1 by 2 pi root LC. L is becoming 2L and C is also becoming 2C. This is root 4. So F0 is 1 by, if you take here, okay, 4 pi root LC. That is 1 by 2 into previous case, previous F0. Let us say F0 dash. Because 1 by 4 pi root LC. That means now the new frequency is previous frequency by 2. Now this new frequency is previous frequency by 2, because previous frequency is 1 by 2 pi root LC. But I can write it as 1 by 2 into 1 by 2 pi root LC. That is half of that. So previously if the frequency is 1 kilo, now what is the frequency? By 2. So this is 1 kilohertz by 2. So answer is 500 hertz. 500 hertz. Okay. Yeah, 0.5 kilohertz. 0.5 kilohertz. Very good problem, na? Because he changed the topology. And topology will affect the natural frequency. Topology do affect the natural frequency. You remember in my notes, when I was discussing a very important concept, I told that in one problem I asked, what is the resonance frequency of this circuit? Do you remember? What is the resonance? This is 2 farad, 1 Henry, 1 ohm. Okay. And I also modified this by changing the topology. Like I interchange the position of inductor capacitor now. I interchange the positions of inductor and capacitor. Like this is now 1 Henry, this is 2 farad and this is 1 ohm. In both cases, I asked you to find resonance frequency. Now how to find resonance frequency of such circuit? What you do now, sir? Yes, find the total impedance and equate the net reactance to 0. Okay, find the total impedance and equate the net reactance to 0. So in this case, if you try to find the impedance, okay, first capacitor minus J by omega C plus these two in parallel, one in parallel to J omega L. Then you rationalize this, separate real part, imaginary part. In this case, what I will do, in this case also Z will be this plus, this is plus J omega L plus here 1 in parallel to minus J by omega C. Now if you do, and we know finally in both cases, yes, at omega equal to omega naught, net reactance will be 0. That is a condition for resonance. Here also same thing, that at omega equal to omega naught, yes, at omega equal to omega naught, okay, net reactance will be 0. Now if you do both, you see, sir, in this case we get omega naught as 1 radians per second. Obviously 1 radians per second, but in this case you will get omega naught as half radians per second. You see, you check it. But interesting conclusion is that topology of a network will change its natural frequency topology. That is why here also what happened? Topology changed. Inductor double, capacitor double, okay? Values double, here also topology double. So natural frequency of the circuit depends upon topology. That means if you change the nature, natural frequency will change, sir. That is the meaning. That is the clear evidence. You check it. Here you will get omega naught as 1 radians per second. Here you will get omega naught as only half radians. That is a very interesting conclusion. Okay. Now this is an unique question I selected and I want to do this. Though it is a tedious process to do, I want this, sir. Very good practice. All fundamentals will come. The intention of taking this book and doing here is to give you completeness of the subject in that chapter. See this question, I want everyone to listen. The circuit of figure, in the circuit of the figure, mutual inductance exists between the two coils. Okay. The coefficient of coupling being K. So here what is K? K is the coefficient of coupling. K is what, sir? Coefficient of coupling. And K ranges from 0 to 1. Find the value of K if the power lost in the resistor is 32 watts. Find the value of K if the power lost in the resistance is 32 watts. Also calculate the power loss if the terminals of one of the coils are interchanged. Okay. First, find the value of K if the power lost is 32 watts. And also, now he is asking, calculate the power loss if one of the terminal coils are interchanged. Okay? Chalo. Yes, let us do that. First of all, he gave power lost is how much? 32 watts. Okay, now, to find power lost, I need RMS current. Yes or no? RMS current, yes. So, we know, yes, that is power lost he gave. That power lost is 32 watts. That is I RMS square into R is 32 watts. So, I RMS square into R. R is how much he gave? 10. 10 is 32. From that, if you do, I will be root 32 by 10. That much current will come. Okay. Yes, I will tell you the calculation, but let me first write. But we also know I is V by Z. But we also know I is V RMS by Z. That also we know. Now what is Z? Z is root of R square plus XL square. Finally, this is X. Okay. Now my intention of calculating K, which is coefficient of coupling, is equate this. One way current we will get and one way from this also current we will get. Both must be equal and that's Z. But what is Z? You know, Z is root of R square plus X net square. X net square. But I also know that Z is V by I. Z is V by I. Chalo, what is V he gave? VRMS is 20 angle 30. Don't worry about angle right now. Magnitude we are talking. Magnitude of V is 20 and I magnitude is this. Okay, I did the calculations, sir. Everyone open calculator and check it. Yes, everyone open the calculator and check it. Now if you do that, yes, after solving, okay, yes, if you do this I, okay, you will get 1.7888. Now if you substitute this I as V by Z, that is 20 by 1.7888, you will get this as 11.18 ohm. Chalo, 11.18. But Z is what? Root of X square plus R square, na? But Z is root of R square plus X net square. R square is how much? 10 square plus X net square. Now I am slowly trying to find K. To find K, which is the coefficient of coupling between two coils. And these are reactances. So I am trying to link there. Chalo. Now Z is how much we got? Yes, 11.18 is root of 10 square plus X net square. Chalo, someone solve it. I will give the value after solving. Yes, after solving, you will get X net as almost 5 ohms. Okay. Yes, after solving, you see X net, you will get it as 5 ohms. So until now, everyone should understand, sir. I am giving you time to observe. See, first of all, power lost in R is 32. Power lost is IRMS square into R. IRMS square into R. Okay? Yes. That is 32. From that I value I got. Also we know I is V by Z. Okay. From that Z also I got. I got, Z I got. But Z is root of R square plus X net square. From that X net I got. X net net reactance. Now from here we will take over to find reactance and then the K value, which is coefficient of coupling. But you know, these two coils are dash connected. Can anyone tell me? These two coils are parallel aiding. Why parallel aiding? If I take some current, that current will divide into two components. Both entering dot, na? Yes, this is clearly parallel aiding. Now in parallel aiding, First of all, we know that, yes, L total is L1 L2 minus M square by L1 plus L2. Now parallel aiding means more answer. More answer means denominator should be less. Parallel aiding means more answer, denominator. So minus 2M. Minus 2M. Okay? But we know I need X net. But X net is omega L total. X net is omega L total. So if you take in the numerator omega L1 L2 minus omega M square by, yes, L1 plus L2 minus 2M. But this is not enough to write in terms of reactances, and I need the value of K, because reactances he gave. Inductive reactance of coil 1 8 ohms, inductive reactance of coil 2. So this is very important trick. Now after coming here, see, interestingly, I will multiply and divide by another frequency, omega. Omega by omega. So now we can conclude. Yes, now this is very interesting. Now if you observe, this I can write it as omega L1 into omega L2, and this is minus omega square M square. Omega square M square is, already we know M is K root L1. So M is K root L1. So K square L1 L2 by denominator omega L1 plus omega L2 minus 2 omega M. M is K root L1 L2. Okay, so omega square. M square is automatically K square L1 L2. Chalo, yes or no? I will further simplify that X net. Chalo, X net is, now that is omega L1 into omega L2, okay, minus K square into omega L1 into omega L2, denominator, yes, omega L1 plus omega L2, okay, minus 2K. If you take omega under the root, if you take omega under the root, it becomes omega square na? That omega square, again I will write it as omega L1 into omega L2. Okay? But this omega L is reactance. So finally this X net, chalo, I will write in terms of reactance. That is X1 into X2 minus K square into X1 into X2 by denominator X1 plus X2 minus 2K root X1 into X2. Chalo. Now sir, already for the given data of loss of 32 watt, we already got X net how much? 5. We already got net reactance how much? 5. We got net reactance 5. And he also gave X1, X2. X1 gives to how much? 8 and 5. Net reactance is 5. But X1, X2 also, yes, 8 and 5. Now from that can't we find K? Chalo, let us substitute now. If you substitute, this is 5. Okay. This is again how much? 1 is 5 and 8. Okay. 1 is 5 and 8 minus K square into 5 and 8 by denominator 5 plus 8 minus 2K root 5 8s are 40. Now you solve this, sir. Interestingly, you will get K. Chalo, you solve this, you will get K as 0.79. Outstanding problem. Outstanding problem. But in this, everything we are learning. First of all, power calculations in AC. Okay. RMS. Of course, power is RMS, of course. And given directly polar is RMS. Now don't confuse, sir. If function would have been given like Vm sin omega t, then Vm is maximum. Then RMS is by root 2. But directly polar is considered as RMS. So directly 20 and RMS, yes, we got that itself is 20 and current we got, and from that impedance and reactance. And with all this difficulty, yes, finally here 2 coils are in parallel aiding. Okay. And from that we wrote in impedance form and reactance form. And if you solve for K, you got this. That means concept is, if I can make this coefficient of coupling almost 7.79, almost 80, that is 80% of flux common to both the coil, then the power loss is how much? 32 watt. Now sir, very interesting. See the second part. Also calculate the power loss. Also calculate the power loss if the terminals of one of the coils are interchanged. Also calculate the power loss if the terminals of one of the coils are interchanged. Okay. Also calculate the power loss if one of the coils are interchanged. Okay. Interchange. Chalo. Interchange. So he is telling that yes, interchange one of the coil terminals. So what I will do? See, as long as the distance between the coils and the permeability of the medium is changed, if you reverse one of the coil, automatically, yes, series, they become parallel opposing. So he's saying that one of the coil terminals are interchanged. That means this you connect here, this you connect here. They become parallel opposing. So yes, as long as the distance is same, okay, and permeability is same, okay, if you interchange, the connection become parallel, yes, opposing, parallel opposing. So in parallel opposing, if you go, the same formula, how I can write in parallel opposing, same thing will go on, but plus will come here. Yes or no? Same thing. But will coefficient of coupling change? No. But as long as the distance is same and permeability same, K remains same. K remains same. Now it is ulta. That means for the same K, parallel opposing is asking power, reverse. First thing is so good that for the given power, parallel aiding, all this we got. Now reverse. Now for the same thing, parallel opposing, for the same K, how much power is asking? Just reverse, sir. Simple now. So now the same formula if I write here, you see this X net. This X net is X1, X2 minus K square into X1, X2 by, because it is parallel opposing. So this denominator will be X1 plus X2. This is plus, yes, plus, okay. This is the denominator here, okay. Plus 2K into root, okay. Plus 2K root X1, X2. Now reverse. Now for the same K substitute here, X1 5 into 8 minus K square 0.79 square into X1 X2 5 into 8 by 5 plus 8 plus 2K, this is 0.79 into root 5 into 8. You will get this X net as, now reverse, okay. I already calculated, sir. Yes, you will get this X net as, reverse you go now, okay, all together you will go 0.653, okay, 0.653. Now once you got X net, what is impedance now? Yes, once you got X net, reverse, then Z is root of R square plus X net square, 0.653 square, okay, then you will get this impedance as, okay, then you will get this impedance as 10.02. Then RMS current is again V by Z. V is 20 by Z is 10.02 and you will get this as 1 point. Yes, you will get this as, yes, 1.995. Then power is this IRMS square into R. R is 10. So this is 1.995 square into 10. Yes, you will get this almost as, yes, you will get this almost as 39.8 watt. 39.8 watt. Okay, you will get this as 39.8 watt. Chalo. So we'll conclude. That means parallel opposing means net reactance decreased, current increased, so power also will increase. Okay. So by doing this problem, all the concepts of magnetic circuits are concluded. So yes, sir, my intention is to come and interact with you. Just doing such big problem is not the intention here, but giving all basics in one problem of all magnetic circuits and its calculations. Okay. So what I would say is, see, note down my number. If you are in ACE Academy or not even ACE Academy or anyone, definitely ACE Academy is there and ACE Online is there to help you. So my WhatsApp number is 9000616124. 9000616124. Please message only, don't call, I don't lift. You message, whatever help I can do from ACE Academy point of view, ACE Online point of view, we are always there. Okay? But don't stop your preparation until you get something, sir. Exam is not about cracking in February or March, and it is not, life is not about just one exam. But continuing preparation until you get something is called consistency. And the students who are consistent in life, they always keep growing, and there is no limit. So don't give up until the last moment. And the intention of this booster score is just to give you confidence, just to interact with you, okay, wake you up, something like that in preparation, and don't give up. All the best. Okay, I will be there, and my WhatsApp number is 9000616124, and my name is Krishna Verma, faculty in networks in ACE Academy. 9000616124, Krishna Verma. Okay, do message me any doubts and anything you want to share. Yes, I will definitely share my personal notes, material, etc. And I'm always there for your doubts. All the best.